Hi-oh, here we are again, solving parallel circuits this time, a basic parallel circuit. It's very similar to the series circuit, one that we did. Again, we're going to call the resistance of this resistor, resistor 1, resistor 2, resistor 3. It doesn't have to be one, this could be resistor 3 if you want. I just chose it to be resistor 1 because it was 1 ohm. The battery supplies 12 volts. We have, you can find out things at point A, B, C, and make more points if we want. It doesn't matter. Just like with series circuits, I don't worry about trying to solve all that stuff. I just solve everything and then look back at the questions. So here we go. We have our basic formulas for resistance, voltage, current, and Ohm's law. What do we know? There's one thing we can solve right away. And there it is. If we know the voltage one place, we know it every place. Look at that. It's a 12-volt battery. Therefore, we know there's 12 volts going across that resistor, 12 volts across that one, and 12 volts across that one. How about that? What else can we find? Well, we could certainly do this. We can say, well, V equals I times R. We know that is Ohm's law. We could certainly solve for I in each one of these situations for each resistor. So let's say resistor 3. We could solve for I. We know the voltage equals 12, and we know the resistance is 3. So what do you know? In which case, 3 divided by 12 is 4. So this is 4 amps. We could use Ohm's law again. The voltage is 12 for the second one. Voltage is 12. We're solving for the current. The resistance is 2, so it looks like 6 amps. Wow, look at what's going on. Less resistance means more current. And of course, this other one, we do it again. It's 12 amps. So look at that. We have determined the voltage, current, and resistance across each resistor. We could then use this formula and say, well, how much current does the battery supply? Well, the total current supplied by the battery is the sum of all these. 12 amps for resistor 1, plus 6 amps for resistor 2, plus 4 amps for resistor 3, and that comes out to 22 amps. Look at that, 22 amps here. And then we could either use this formula, which is a mess, to find the total resistance of this circuit, or we could just use Ohm's law again. V equals I times R. We could find out how many ohms of resistance this battery experiences. Well, we know it's 12 volts, 22 amps. Solve for R is 12/20 seconds, which is what, 6/11. So there you have 6/11 ohms. There you have it. We've solved for everything. The only thing we didn't do was answer those 3 questions. If adding another resistor in parallel, so let's put one across here, what happens to the voltage? What do we know about the voltage? Well, we know it one place, we know it every place. Adding another resistor didn't change the voltage of that battery. You put a 1.5 volt D-cell battery there, it's still 1.5 volts regardless what you put in the circuit. So that stays the same. Well, by adding another resistor in parallel, what happens to the current across any one resistor? Well, let's think about that. We know the voltage, even though we add another resistor, we know, let's say resistor 1 is 12 volts. The resistance is still the same of that resistor, regardless if we had 1,000 new paths. We didn't change the resistance of that first resistor, and we know the voltage stays the same, therefore the current stays the same. Well, think about that. Your house is in parallel, and as you turn on devices, the amount of current in each device does not change. The current being drawn from the battery does, or from the electric company does, but not through each device. Last one. If we add another resistor in parallel, what happens to the total resistance? Well, we know this relationship here, and if you remember from a previous podcast, as we add more paths, it makes it easier for the current to flow. So what happens to the total resistance? The total resistance decreases.